Our project for Innovate Malaysia 2020 is the Swiftlet detection with computer vision and machine learning. Our project is called the Swiftlet surveillance system, and we keep an eye on things. In this project, there are two team members, which is Lo Jia Chiu and Vicky Ding Ding Hui. Mr. Ling Ting Sun, on the other hand, is our supervisor. I, Vicky, will now brief on part 1, which is the elevator pitch. In this, we will first start with the problem statement. So, right now, the owner of the Swiftlet house have a problem where they are constantly required to check the Swiftlet house to make sure that there is a presence of Swiftlets there. The problem that they are actually facing is that is the time convenience, as they constantly need to check out the Swiftlet house. Hence, we will focus on the solution is to focus on the problem regarding the owner of the Swiftlet house, where they have to constantly go to the Swiftlet house to check if the presence of the Swiftlet is there. The limitation of the solution is not efficient, as the owner has to spend their time on their own to go and check the Swiftlet house. The solution that created by us is that we first prioritize the owner in regarding to their time, where we want to make sure that they are able to save their time. The owner can check the situation of the Swiftlet house by accessing through the internet. Is our idea. So the owner do not have to go to the Swiftlet house physically. Through the help of the internet, the owner can understand the situation and condition of the Swiftlet house well through the use of camera and sensors. The feedback we got is that they can watch the Swiftlets as well as the living condition of the situation in their own house without having to be physically there. The owner of the Swiftlet house can benefit from this solution is because most of the Swiftlets house live far from their living environment. The reason is that the Swiftlet house is noisy and it can be very unhygienic, which the owner of the Swiftlet house do not want to affect to the neighbor surrounding. In Malaysia, there is a lot of Swiftlet house, so there will be a lot of Swiftlet house owner. The solution will allow to determine the most effective method to track Swiftlets, so they can observe it anytime, anywhere, as long as there is the internet for them. And that is all from me. Thank you.
Hi, this is Yachu, and I'm from team MY072, and now I'm going to talk about the technical part for this project. So for the hardware, we use 2 Raspberry Pi, 2 camera, 1 Arduino Uno, and 1 DHT11 sensor. So this is separated into 2 units. One unit is used for indoor, and another unit is used for outdoor. For outdoor unit, it actually uses the Raspberry Pi Zero and the normal 5 megapixel camera. For indoor unit, we use Raspberry Pi 4, the infrared camera, we use the Arduino Uno and the DHT11 sensor. The sensor is connected to the Arduino, and the Arduino is connected to the Raspberry Pi Crew serial communication. So for this project, the programming languages that is used is Python and HTML, PHP. Mostly used is Python, because what we need is The computer vision and the HTML and PHP is just for website browsing. And for machine learning algorithm, it is actually a support vector machine. Okay, the reason that we use support vector machine is it actually gives high accuracy, and other than that, it can be trained very fast with low computational cost. But there is several disadvantages too. First, that it cannot detect like exactly real time. It has a certain latency, but yeah, that's one of the disadvantage. Other than that, since we are training this SVM model with only 86 images of Swiftlet and 102 images of Swiftlet house, we actually has combined images of less than 200 images, so which is kind of bad because the more data that we got, we can train the better model. Other than that, we have imbalanced data. So what you can see here is we have 86 positive images and 102 negative images. Basically, if you want to train a good model, we need to have equivalent numbers of images here. But since we can't really do that, so yeah, that's it. We just use 86 images of Swiftlet and 102 of images of Swiftlet house to train the model. So this linear SVM is trained with 90% of the images and 10% is used for the testing. So the result of this SVM is acceptable because it actually has a testing accuracy of 80%, which is shown here. Yeah, 0.8. Yeah, so the model is later saved into this Swift HOG SVM.pico. And this is the confusion matrix of the testing, and these are the sample output. So let's see. So for example, in this case, this is actually a Swift. This is actually a Swiftlet, but the model detect it as not non-Swift. Other than that, you can see from this case, it is actually a ceiling, but which is non-Swift, but the model detect it as Swift. So yeah, there's some error here and there. So now I'm going to show my project. So from what you can see here, this is actually the model that we created. So let's see. So we import all the images from these two directory and then separate it into two labels. 0.9 is used for train and then 0.1 is used for testing. So first, we read the images in grayscale. So this is back to the image processing that I talked about just now in the first part. Yeah. So first we make it into grayscale, and then after that we resize it, and then we straight away put into the HOG to get the feature vectors. This is what we do to train the model. But in our testing, let's see, for indoor, right? For indoor testing, we actually use a background subtraction method with KNN. So let me find, yeah. We create a background subtractor KNN, and then we change the image to grayscale, we blur it. Yeah. And then after that, we dilate the image, and then by thresholding it, we make it into binary. Yeah. And then that's it for the image processing. So here you can see that we actually import the classifier, which is the model that we trained just now, and then we put it at, let me check, we put it at here. So in this part, we actually change the item detected, the moving objects that are detected, to the HOG, and then we put it into the classifier to detect the label. So if this label is equal to label 0, which is the Swift, where is it? Which is the Swift, yeah, right here, it will actually show on the output. So let me just run this code. Yeah. and let's see the output of it. So I think I'm going to pause because it might take some time. So yeah. Okay, so from the indoor you can see that this is actually infrared mode, and you can see that it detects the moving objects. Yeah, it detects the moving objects. Yeah, it has some misclassification too, as it detects this light as a swiftlet. So you can see when the birds, I mean the swiftlets are flying around, it can detect it quite okay. Yeah, you can see that it detects the moving swiftlets. Okay, so now I'm going to talk about outdoor. So for outdoor, we do the same thing, import the model, name the labels, and then for outdoor, it is much more simpler because for outdoor, right, what we detect is we look at the sky and then we look at the birds. So actually, we just need to convert the color to grayscale, blur it, and then we just need to do the simple image thresholding, dilate it, and then we find a control to detect the birds. So after that, we actually put the object detected into the HOG to get a feature vector, and then we use this feature vector to test if it is a swiftlet or non-swiftlet. So I'm going to run this code now. If it is swiftlet, it will show on the output. So I'm going to run this, and let me see if I have to pause or not because it might run slow. Yeah, so it's okay. So as you can see here, the green one is actually what our model detect as swiftlet. So the rest of it, our model don't think that it is swiftlet, so it doesn't detect it. So there is consider that this model is working still okay, still fine, because it still detects the swiftlet. Yeah. So that's it for the model testing, the machine learning method on the indoor and the outdoor. Okay, so now all we want to do is we want to try uh, the website. So actually the circuit is connected together. So if I run this code, yeah, and I go to, let's see, and we go to this website, we are able to see the live data of the Raspberry Pi 4. So in this case, we can see that there is this live temperature of 23 and humidity of 53. This is actually the temperature and humidity of my room now. And let's go to the indoor camera. So you can see that this camera, we can access it correctly. Yeah, so it works good. And so let's go back to the main page, and you can see that it actually keep refreshing the data so it can get the latest data. So other than that, we want to prove that the communication between the Raspberry Pi 0, which is the outdoor camera that can send the data to the indoor Raspberry Pi. So let me just run this. Yeah, as you can see, the 127 is actually the normal camera. So you can see that it actually detects like 1, 2, 3, 4, 5, 6 things on the wall. So this is what we want. So even though you can see that the thresholding, we can see that there is noises here, we actually don't care as it is not what we want. We only want the small part of it. So it means that this model actually works fine and working as intended. So let me just come back to here and go to indoor camera. Yeah, it's working good. And that's the demo for now. So in conclusion, we can we can say that the machine learning algorithm is actually working, that it can detect swiftlets, but there is still some misclassification as we don't have enough data to train it to get a precise, accurate the result that we want. But it is sufficient for the current problem because the owners can now stay at home, just look at the phone and look at the situation of the Swiftlet house. So in future, other machine learning model can be used, or even deep learning can be used in this Swiftlet detection model. So overall, this system is working just okay, and it has a lot of room for improvement. Okay, thank you.